For the events A and B is given that the probability of A is equals to 0.7, the probability of B is equals to 0.6, and the probability of A given B prime is equals to 0.8. Find probability of A intersect with B prime. Okay, so for part 1, all you do is what we can do is we use the definition. Right, so if we have the probability of A intersect with B prime, we can also say using conditional probability that this is the same as the probability of A given B prime multiplied with the probability of B prime. Right, then what's the probability of A given B prime in the question? It's just equals to 0.8. And probability of B prime, we look at what we are given. We're actually given a probability of B, right? This is equals to 0.6. So probability of A given B prime, this can be the same as the 1 minus the probability of B, and the probability is 0.6, right? And so our answer finally comes out to be 0.8 multiplied by 0.4 to give us 0.32, right? And this is for question 1. Okay, how about part 2? For part 2, we are required to find the probability of A union B. So probability of A union B, given what we know, it may not be very clear. So what we can do is we can maybe try to draw a Venn diagram. Like, so we can draw a Venn diagram. So we have our A, right? This is our A. This is our B. Okay, and we know that the probability of A is equal to 0.7, right? We know that A intersect with B prime, okay, given A intersect B prime is 0.32, so it means that A intersect B prime should be somewhere here, at this portion, right? A intersect B prime should be over here. We know that this is 0.32. Alright, how do we find A union B? So we can say that A union B, if you think about it, it's just like a red color portion plus the green color portion, and the green color portion is just the probability of B. The red color portion is just the probability of A intersect B prime, right? So looking at the diagram, you can see that the probability of A union B, right, is just the red portion plus the green portion. It's the same as the probability of A intersect B prime plus the probability of B. Alright, this is equals to, from part 1, the probability of A intersect B prime is 0.32, and from the question, we know that given to us, the probability of B is equal to 0.6. Right, so our final answer comes out to be 0.92. This is for part 2. Okay, so part 3, we are asked to find the probability of B prime given A. So the probability of B prime given A. Alright, we can use our conditional probability to help us. We can say that this is the same as probability of B prime intersect A over the probability of A, right? And probability of B prime intersect A is the same as the probability of A intersect B prime. Are we right? Am I right? And probability of A intersect B prime, you recall this is something that was found in part 1. Right, so this is found in part 1. So from part 1, we know that the probability of A intersect B prime is just equals to 0.32. Right, probability of A, given in the question, is just 0.7. Right, and our final answer comes out to be 16/35. So most of the time, to solve questions like this, we always think whether can we straight away directly use the formula. If we cannot, we draw a Venn diagram out. We draw a Venn diagram out and see the portion that we want. Is there anything? So like for example, in part 2, we draw the diagram and we look at the question and say, is there any part that I know? Is there any part of the answer that I'm finding that I know? And then I can use a different color to shade, right? So that will help you. So for part 4, for third event, it's given that the probability of C equals to 0.5. A and C are independent. So what does this tell you? So straight away, you can straight away say that given intersect C, this is the same as the probability of A multiplied by the probability of C, right? So If A and C are independent, then we can also say that, A prime and C are also independent, correct? So this also means that A prime and C are independent, right? So it's given. We also know that if A is independent, no matter what A happens to A, C is not affected. So whatever happens to A prime, C is also not affected. So the probability of A prime in part 4, if we are going to find the probability of A prime intersect with C, this is just equals to, because you know that they are independent, right? This is just the probability of A prime intersect with C. Alright, the probability of A prime intersect with C. What's the probability of A prime? Okay, E is just the 1 minus the probability of A. Alright, what's the probability of C? Probability of C is 0.5. And 1 minus probability of A is just because probability of A is 0.7, so we're looking at 0.3 multiplied with 0.5, and the answer comes out to be 0.15. Alright, hence state an inequality satisfied by A prime intersect B intersect C. So if we look at the question, alright, the question, there's a hence, so it means that this is hence related to this. So how is this related? Alright, we can't really tell. Maybe we can use a Venn diagram to help us. Alright, if I draw the Venn diagram, I have A, B, and C, right? So this is A, this is B, this is C. Alright, where is the portion for which I have A prime intersect C? A prime intersect C will be probably somewhere here, right? I'm going to put it in blue. Right, you can see this blue portion here is A prime intersect C. And what is A prime intersect B prime intersect A prime intersect B intersect C? A prime intersect with B intersect with C is probably somewhere here. Right? So this is the region. This is A prime intersect B intersect C. And one inequality you can see is that A prime intersect B intersect B, C actually lies in, or you can say it's a subset of A prime intersect C, right? So because it lies inside, we can also say that the probability of A prime intersect B intersect C is going to be less than the probability of A prime intersect C is a proper subset, correct? And here, what's the probability of A prime intersect C? This is where you use the hence part. The hence part tells you that in part 4, the probability of A prime intersect C, as you have found, is 0.15. Right? So the probability of A prime intersect B intersect C is less than or equals to 0.15. Right, there's a hence, so the hence tells you that you have to be using this, and we are done with question 1.